More problems on welding. Design a fillet weld to join the tension member consisting of two ISA 100 by 75 by 8 mm to a 12 thick gusset plate. The factor tensile load is 410 kilonewton. So in this particular problem, they did not inform whether the two Indian standard angles are to be placed back to back or in a same side. If nothing is given, you can consider back to back or same side. Anything is okay. So here we will be considering the angle sections are placed back to back, and also let us assume the longer leg is connected to the gusset plate like this. So this is the leg. Longer legs are connected to the gusset plate. This is the gusset plate here having 12 thick. These are the welds. The fillet welds are done on the four sides here. So in the front view, you can find only two sides. So here, this is the factor load 410 kilonewton applied. So these are the length of the weld at the upper side and lower side. This is L1 and this is L2. So now the size of the weld for rounded edge. So usually here we get the rounded edge. For rounded edge, the welding size should not exceed 3/4 of the thickness of the plate. So 3 by 4 into 8 So which one is to be considered? Whether thickness of the ISA angle section or gusset plate. So the thickness of the plate or thickness of the angle, whichever the value is small, we have to consider that. So at the top, the thickness shall not exceed t minus 1.5, that is equal to 6.5 mm. So this is not a round edge, therefore it is t minus 1.5. It is 6.5 mm. Therefore we provide the size of the weld as 6 mm. So the throat thickness works out to be zero point 0.7 times S, that is 4.2 mm. From the steel table for ISA 100 by 75 by 8 we get the CG distance is equal to 31 The factor tensile load carried by each angle is equal to 410 by 2, that is equal to 205 kilonewton. So whatever the load is there, it is equally shared by the angles. So divided by 2 will come into picture here. The design strength of the weld PWD equal to LW into TT into FU by root 3 into gamma MW. So upon substitution we get 795.38 LW. Therefore we will equate strength of the weld to the factor load. Equating them, we get length of the weld equal to 257.74 mm. Now L1 and L2 are the length at the top and bottom of the weld as shown in the figure. Now CG of the angle section is actually at a distance of 31 from the top of the angle section. To find out the length of the weld at the top and bottom, the CG of the weld should coincide with the CG of the angle. So here this is 31 CZZ, this distance is 31 or to be precise, yeah, it is 31 Now when I take moment, I get L1 into 31, which is equal to L2 into 100 minus 31, or L1 equal to 2.2, 2.22 L2. So we have LW equal to L1 plus L2. Upon substitution, we get L2 equal to 80 and L1 equal to 177.6 Therefore, let us provide L1 equal to 180 and L2 equal to 80 So the total length of the weld equal to 260 Now let us take one more problem. A tie member 75 by 8 is to transmit a factor load of 90 kilonewton. Design the fillet weld and calculate necessary overlap. So this is called as the overlap. The x distance is called overlap in the case of lap weld. So here we will assume the welding is done on both the sides of the tie member. Let x be the overlap and LW be the effective length of the weld. So this is 75 75 by 8 according to the given problem. 90 kilonewton is the load. Now the maximum size of the weld is given by 8 minus 1.5. It is not a rounded edge, so therefore 8 minus 1.5. If it is a rounded edge, then it will be 3/4 of thickness of the or smallest thickness of the plate or the member to be connected. it is equal to 6.5 mm. Therefore, also minimum size of the weld for 8 mm thickness equal to 3 mm. Let us adopt the size of the weld equal to 6 mm now. Now let us also calculate effective throat thickness. The effective throat thickness is given by TT equal to 0.7 into 6 into or 0.7 into 6 works out to be 4.2 mm. Now design strength of the weld PWD is calculated by using this formula. We know this formula works out to be 795.35 Lw. Now the total load to be transmitted equal to 90 kilonewton. Let us equate the load to the strength of the weld. We get length of the weld equal to 113.15 mm. Now let us find the overlap. So the total length of the weld to be provided equal to x on the top and x at the bottom. Total is the length of the weld. So 113.15 equal to 2x. Therefore the overlap x equal to 57 mm. 56.57 we get. We will approximate it to 57 mm. Also, let us take a problem here. A tie member of a roof truss consists of two ISA 75 by 125 by 75 by 10 mm subjected to a pull of 250 kilonewton. It is a factored pull. The angles are connected on the same side of gusset plate of 10 mm thick with long legs back to back. Design the weld. So this is how the given problem look like. These are the long legs. Long legs are back to back, and these ISA, the angle sections are connected on the same side of the cassette plate. This is the cassette plate, the hatched one, 10 mm. This is how it will be viewed like, and this is length of the weld at the top, length of the weld at the bottom. Only two places we can do the weld here. Now the size of the weld equal to 3/4 of 10 mm works out to be 7.5. Let us call S equal to 6 mm. Size of the weld x 6 mm. Now Fu equal to 410 Newton per millimeter square, and let us assume it as a site weld. For a change, gamma mw will be 1.5 instead of 1.25 for shop weld. Let P1 and P2 be the strength of the weld at the top and bottom. Therefore, strength of the weld at top equal to P1 equal to L1 into TT into Fu by root 3 gamma mw. Upon substitution, we get 662.798 L1 Newton. So similarly, strength of the weld at the bottom is also equal to the same. Now, P1 plus P2 equal to P. By default, P should be equal to P1 plus P2, works out to be 250 kilonewton. Now, let us take moment of the force P and bottom of the weld about top of the edge. So, P2 into 150. Let us take moment at the top, P2 into 150, which is also equal to P into 75. P into 75. So, upon substitution, we get L2 equal to 190 mm. Further, the total length of the weld is given by Lw. Therefore, strength of the weld for total length, overall length equal to Pwd equal to 0.7 into L, 0.7 into 6 into Lw into Fu by root 3 gamma mw works out to be 662.798 Lw. Equating the strength of the weld to the load, that is 250 kilonewton, we get Lw equal to 377, works out to be or rounded off to 380 mm. Now, total length of the weld equal to L1 plus L2, which is nothing but 380 equal to 190 plus L1, or length of the weld at the top equal to 190 mm and at the bottom is also equal to 190 mm. In the next video lecture, we will take a few more problems. Hopefully, the next video lecture will be last video lecture in this module. Thank you for listening.